Okay, so great. As you can see, so to start with the workbench, so first of all, no, to start with the Ansys, we don't have any, specific tool with the name Ansys. So Ansys has multiple tools which, for the different physics, you can say. So depending on the problem, we need to take a specific tool and we need to work on. So we have one workbench. So you just need to search for workbench. Okay, and currently we are using workbench 2021 r1 version, so you just need to launch this. Okay, so it looks something like this. So this is the workbench view that we have over here. And what is this workbench exactly? So it is a workbench is nothing but a tool handler. So here you have access to the various tools within a single place. So what is the advantage of having workbench? First of all, so here you can work on multiple projects at the same time. Okay, and you can see all the you know different tools together, so you can combine them and you can easily transfer the data from one physics to another physics with the help of workbench, which is very easily possible. So let's say you wanted to start with the CFD problem. So you can see on the left side we have various analysis systems over here. Then on the bottom side we have the component systems available, and then we have custom systems, design exploration, and ACT tools. This is the project schematic what we have. On the top side we have various options available. uh, we have various options available for, as per the requirement, like we view tools, units, etc. Okay, so to start with any problem, let's say I wanted to work on a CFD problem. So what I need to do is I need to take this fluid flow fluent analysis system. So how, what you need to do is you need to drag this, and when I select it, you can see one green box is appearing over here. So you just need to drop it in this green box. Okay, so you can see you'll be able to see this complete analysis system over here, right? Now, this analysis system consists of various components inside that. So you can see the geometry component, mesh component, setup, solution component, and result component, right? So these are nothing but these different components. So same analysis system we can prepare from with the help of component systems. Okay, so let's say first we have geometry. So let's take a geometry over here. So I'll put it in a sense second row. Then I'll add the mesh with that. So to add a mesh, there is a two different ways. Okay, so I have taken this mesh, but I want to share this geometry. So what you need to do is drag, click on this geometry and drag it toward the mesh. So you can see when you're dragging to the mesh, it is saying transfer B2. So this is B and this is 2. So it is directly transferring or sharing that particular geometry with the mesh file. Okay, so it's very easy. And then you can take another, that is fluent. Okay, so drag this fluent and drop it. So another way of sharing the data is directly you can drop it on the mesh. It will automatically transfer data. And then the last one is the results. So you need to take a results, and that's all. So this is nothing but a complete analysis system which is made up of four different components, what you can see over here, right? And this is also one analysis system what we have. Both are same, this one and this one both are same. Okay, but way of creating them is different. So why it is required like this? So let's say for a same geometry I wanted to have multiple meshes, right? So what I can do is I can share the same geometry with the multiple mesh, where I can have different mesh settings each time and I can solve that particular problem. Okay, so this is how very easily you can transfer the data from one analysis system to another analysis system, from one component system to another component system, very easily within the workbench. So that is the reason workbench is very important over here. Okay, so I hope you got this. And then on the left side, you can see in the file here, you can open new workbench file, you can open the existing file, you can save this file. Okay, so to save this file, so you let's say I'm saving it on the desktop somewhere in this folder. Okay, let's say I'll save with a name 1 2 3 4. Okay, so this is the workbench extension, that is .wbpj. Okay, so this is the workbench extension in which it will get saved. So here, let's say I am working on multiple problems. Let's say this is a CFD problem, and then I am taking the mechanical as well. So for mechanical, I need to take the static structural. So I am adding static structural here. right? So likewise, I can work on then steady state thermal. I can work on multiple problems within the same file. Okay, so no need to create a separate file each time and save it separately. So within a same file, you can just work on the multiple uh, projects. Okay, so that this is also one of the beauty of using the Ansys workbench. Okay, so I hope this is pretty clear to you. And when you save this file at that particular location, it creates two files. Okay, one is the application file, so you can see this is 1 2 3 4. So this is the name what we have given, right? So this is 1 2 3 4.wbpj. So this is the exe file what you have, and it will create one more folder for that. Okay, so these two files it creates. So whenever you want to share your project with someone, you should share both the files together, this file and this file. Otherwise, a person who is receiving the project, he will not be able to open it, right? That is the reason you should save it, share both the files. In other case, what you can do is you can go to the file and then you can go to the archive. So here you can create an archive file format, like a zip file format. Okay, and you can save it in a zip file format as well. So you can see this is a 1 2 3 4, and this is the archive file format. The extension which is used for this is .wbpz. So this is the workbench extension. Okay, so when you are saving in this particular file format, you can directly get that particular file. So you can see whatever the data you wanted to export, it will show you all those data. Okay, and then here you will be able to see that archive file will be created. Mm, I don't know where it created, so let's create it again. Archive. Okay, it is created over here, and oh, okay, it's created somewhere else. Mm, okay, so here I'll create it. So you can see once you create it, it will create a whole separate file. Now you can share only this file. Okay, you can share only this file to anyone, and he can open it. Okay, so that is also another beauty of using the workbench. You can just save the files in a zip file format, so all the files inside this all will be saved in the same file format, and you can easily import those files. Okay, or share with anyone, and the person can easily use it. Okay, so I hope you understood this, and with this we'll start with the our first tool, that is Ansys space claim. Okay, so for the space claim, I'll just delete all this. I don't need this. Okay, so we'll take a geometry component. Okay, so I'll just minimize this analysis systems, and I'll take a geometry component system. Okay, so drag it and drop it over here. So now in Ansys there are two modeling tools. One is a space claim and another one is a design model. So if you right click on the geometry, here you'll get to see both the options over here. Okay, so here you can see, here you can see new space claim geometry or new design modeler geometry. So you can here we are going to learn the new space claim geometry, so which is an advanced modeling tool which Ansys is having. So either you can right click and then click on this, or you can just simply double click on geometry and it will launch the space claim. So here you can see on the bottom side it is showing starting space claim. Okay, so it will launch this space claim into over here. Okay, so it's launching this space claim. So we need to wait until it opens the space claim. So it shows that. Uh, okay, so it's launching the space claim. Okay, yeah. In between, if you need anything me to repeat, you can let me know. I might going a little faster, so you can just inform me if anything you want me to repeat. Okay, I'll try to be slower as well, but If you still feel if any concept you want me to repeat it, you can let me know. Okay. So yeah, so it's launching the space claim. So we just need to wait until it will respond. So yes, it is open over here. So you can see this is the modeling tool which Ansys is having, that is nothing but a space claim. Okay, so in the space claim, I hope you have learned the different modeling tools. So this is also the same kind of modeling tool that is available in the Ansys. Okay, so with the help of this tool, you can very easily create a very good kind of geometry over here, and that can be easily transferred to generate a mesh or with a fluent as well. Okay, so yes, so if you see the GUI of this space claim, so it is pretty simple as you can see over here. So this is the um, the coordinate system what we have in the graphics window. Okay, so this is the graphics area. On the left side we have this structures view over here. Various options are available in the structure. Then we have various options which are related to the different options what we select. So let's say I'm selecting the line option, so you can see you will be getting options related to line. And here whatever the object or model you create over here, so for that model, what are the properties are there, that you can see from this properties menu. Okay, so it is pretty simple. And then on the top side you have various tools, or we can say the tabs available. So in the different tabs there are different options available which are required to create a model, or which are required to repair the model. Okay, so depending on the requirement you can use the various options available. So whichever are necessary tool or options that we need to learn, so that those options we'll see over. Okay, so initially as you can see, when we enter into the space claim, so it directly starts with the sketch mode. So what is sketch mode? Where we can easily create a sketch first, right? And then we can convert that sketch into a 3D model, right? So as you can see, the grid what you can observe over here, which is along xz axis, which is by default. Okay, and if you wanted to change the grid, so let's say you wanted to create a model along xy axis, not along the xz axis, so how you can change that? So here you can see in the mini toolbar, so this is there are various options are available. So you have to select the second option, which is nothing but a select new sketch plane. Okay, click on that, and then you can just rotate the cursor, and you can see different grids are getting highlighted. So whichever grid you need, or whichever plane you wanted to select, just take a cursor to in such a way that that grid will be highlighted. So if you wanted to select xy plane, so take a cursor in between xy axis. If you wanted to select yz plane, then take a cursor in between yz axis. And if you want to select xz plane, then take a cursor in between x and z axis. Okay, so let's say I wanted to select xy axis, so just take a cursor over there and click it, so that grid will be selected, or that plane will be selected. And then we have this option to view in a normal direction. Okay, so plane view, click on it, so it will be viewed this way, and then we can start creating the sketch over it. Okay, I hope it is clear until this. If you get any doubt in between, you can just use a chat box as well, where you can type your query, so I can help you with the by answering the query as well. Okay, so let's start with the creating the model over here. So it will be really simple. You just need to start with the sketching. So first option what you can see in the sketching, that is line command. Okay, so to create a line you need to select the line command. Then you can just you can start a line from wherever you wanted to start creating. So let's say I wanted to create a line from the origin. So take a mouse cursor to origin. You can see the origin is getting highlighted, and then just click over there and your line will be started. You can see you can give a line, you can give the length as well as the angle to describe the line. So let's say I want a line of 50 mm length, and angle, let's say 45 degree. Yes, so you can see, so 45 from x means from y it is 135, so it is showing 35. Okay, 135. So how to switch between these two dimensions? So to switch between two dimensions, we need to use the tab button. the tab button. Okay, so on your keyboard you will be able to see the tab key, so you have to press it to switch between the two dimensions. Okay, so it is very simple. You don't need to click over there. If I'll try to click, the dimension will change. You can see as I am moving the cursor, it is not possible. So what you need to do is you need to just use the tab button to switch between the different dimensions. So you can see whichever is getting highlighted, then you can edit that dimension. Okay, so once it is done, click on enter, the line will be created. So you can see it is a polyline. Now we are in a polyline command, means line command will not exit over there. If you still need to go further, let's say I wanted to create another line of 50 mm, and let's enter it, and then now I wanted to finish the line over there. So either you can press escape, or you can right click, and here you have option finish line, or you can just press the escape key. Done. Now it will come out of that line command, but still means like it will come out of polyline command, but it's still the line command is selected. If you also come out of this line command, again press escape one more time. So you can see now it is not selecting, it is in a select mode, it is not in a line command mode. Okay, so this is very simple, and similar options, or similar way you can create all the different sketches over here. Okay, so let's say now I wanted to create a circle. So select circle, and let's say I wanted to create at 10 10 from this point. Okay, like at somewhere here. Okay, so how I'll do this, take a mouse cursor to that particular point. As you can see, the point is highlighted. Press shift button to give the reference dimensions. Shift, click on shift, so you can see two coordinates appear. Now move the cursor a little bit in that direction, so you can see now you are getting the coordinates, and I will give the dimension as 10, and use tab button again to switch between the dimension and 10. So you can see automatically mouse cursor will relocate to that specific point. Click over there, and then you can create a circle. Okay, so it's pretty simple over here, and very easily you can create a any any sketch with the help of by taking a reference. Let's say even line also you can create with the help of reference. It doesn't mean if I am not telling any command for that particular thing, so it is not available. So see, taking a reference, switching between the dimension. Okay, so taking reference with the help of shift key, switch between the different dimensions with the help of tab key, and these two things are common for all the sketch. Okay, not only for this or something else, it is common for all the sketches. Okay, so that you need to keep in mind. Okay, so let's start, and next is rectangle. Okay, select the rectangle. Now rectangle can be of two types. One is like corner to corner, means you need to select a first corner of the rectangle and then give the length and width. Okay, or you can use define rectangle from the center. So select the center point and then define the rectangle like this. So these are the two different ways, okay, of creating the rectangle. Again, dimensioning is same way. Let's say I want to create a rectangle in this particular quadrant from origin. Let's say it should start at no, I don't want to define it from the center, but it should start from the, let's set 2020 from origin. So I'll take a cursor this way. Now you can see this minus 37. So you should give this as a minus 20, because it should remain in that quadrant only, right? And this is 20. Yes, you can see automatically pointer will go to that particular place, and you can give the dimension. Let's say this is 100 and this is 50, and enter. Rectangle is created. Now I can say this rectangle is at 20 from x-axis and at 20 from y-axis. Okay, so this is how you can take a reference, and this is how you can create a rectangle. I hope it is clear to you all. If you still face any doubt at any time, okay, so you can just let me know if you want me to explain anything again. Okay. let's start with the next command, that is 3-point circle. Okay, so in the 3-point circle, you need to select any 3 points. Okay, so this next command is 3-point circle. You need to select any 3 points and you can create a circle passing through those 3 points. Okay, next one is tangent line. So it should show a tangent line from one circle to another circle. So this way you can create a tangent line. Or if you want in a cross direction, then you can create like this. If you want it like this also you can create it. So this very easily you can create a tangent line as well over here. And then what you can say, next one is the construction line, that is the dotted line. So that also you can create at any location as per the requirement. Okay, so you can create a dotted lines as well, like this. Next one is 3-point rectangle. So here you need to select 3 points, start point, end point, right? Okay, so first start point, then the length and the width, this way. Okay, so this can be created at any angle or anything. So whatever the normal rectangle is there you cannot give any angle, specific angle to that. Okay, so that is the difference over here. Then next one is the ellipse. So in the ellipse, you need to give the major axis and minor axis. That's all. You can easily create a ellipse. Then next one is a spline. Okay, in the spline, you need to give the uh, polyline like this, and you can create a spline very easy. Okay, so spline is nothing but a continuous curve you can see passing through the given different points. So let's say I want to join it over here. So it will be complete smooth curve there. You will not be able to see any corner over. Okay, so that is a spline we have. Then we have the arc. We can create a tangent arc to any specific line. Let's say I want to create to this line. So select this point and then create a tangent arc. Similarly, I want to create with this point, then create it this way, right? So you can create a tangent arc as well to any line, not necessarily only that line is required, any line. So let's say for this line you want to create, you see like this, you can create a tangent arc. Okay, next one is 3-point arc. Here you can select any 3 points, start point, end point, and then you can give the radius. This is how you can create another arc. Then next one is the sweep arc. Sweep arc is something like center, start point, and end point. Okay, so this is the sweep arc that we have, and then next is polygon. So select the polygon. Here in the polygon, you need to select the location of the center. Then you can give the dimensions. And here, how many directions you need or sides you need, you can define it. Okay. Again, you need to use tab button to switch between the dimensions. Let's say I want 8 sides. You give the number as 8. You can see it will automatically change to 8, and angle at 0. And you can see it will be done. So you just need to enter. Uh, it will be done. Okay, so this is a octagon, hexagon unit. Then give 6 sides. Enter hexagon. If you need pentagon, then use 5, and you can create it. So very easily you can create a polygon. Then we have this point. Okay, so here you can select the point, like wherever you require to create a point, you can just select that location and point will be created. You can see here I have created a point somewhere in middle, here also. So this triangle indicates the midpoint, so there I can create a points as per the requirement. Let's say I wanted to join them, then afterwards, right, like this, very easily you can create a points. Okay, so then next one is a face curve. So on any 3D face, we can create a curve. Okay, I'll explain this later. Okay, and now next one is the modification curve. Okay, so first one is creating a rounded corner. So select this. Okay, so that is a uh, fillet we can create from this. Okay, so select the location and then you can easily create a fillet like this. If you don't want to trim the corners, then you can, here we have option disable trimming. So just click, then it will not disable the trimming over here. Okay, like this also you can create it. And then next one is the chamfer mode. So if you want to switch to the chamfer mode, that is also possible. So you can select a corner and you can create a chamfer as well. If you want to enable the trimming for the chamfer, and untick this box, and then you can see it will enable the trimming like this. Okay. Okay, so like this we can easily create the chamfer as well. Okay, so I hope you are able to understand this. And now next one is the offset curve. Okay, so offset curve is you can copy the any specific curve in the parallel direction. I cannot copy it somewhere in other direction. Okay, in the parallel direction only I can copy this. So this is how we can go. If you want in both side, here we have uh, both side uh, option, then you can go in both the directions like this. Okay, so both the things are possible. Then next one is a project to sketch. So this will also I'll explain after some time. Okay, so this is like whatever 3D model you have, and if you wanted to project that to that model to the existing sketch, then this option is used. I'll explain it when we'll create a 3D model. Okay, then this is the create corners. So we can create a corner very easily with this like this. You can see it will extend the line to convert, create a corner, or it will even delete the line as well. So you can see when I'm selecting like this, it should create a perfect corner. So it is deleting this particular lines. Okay, so this is how we can create a perfect corner as well. Okay, then next option is to trim. So you can delete any unnecessary part or unnecessary objects over here. Sketching object. Okay, so that can be trimmed with the help of trim option. And then next one is a split curve. So any continuous curve can be splitted. Okay, so let's say this line I have selected it and I want to split it in between. So I have selected. Now you can see only half will be highlighted. Why? Now it is selecting only half of the line. Okay, select it and uh, trim it again. So like this we can select. Okay, so this way we can trim it. Okay, so this way we can easily uh, split the object. Next one is create curve, like a bend. Okay, so with this we can convert any straight line into a bend. As you can see, select this command and select any straight line and drag it to convert it into a bend. This. Okay, like this we can convert any straight line into bend over here, as you can see, like this. Okay, so this is the bend option that we have. And then next is mirror. Okay, so mirror objects is something like, let's say I'll create a line over here and I wanted to mirror this. So along this line, first you need to select a plane or mirror plane. Okay, and then select the objects which you wanted to mirror. This. Okay, likewise, whichever you want to mirror it, you can select all of them across that line and those will get mirrored. Okay, so this is how we can use the mirror command. So I hope all these sketching tools are clear to you. If you want me to repeat any of the sketching tool, please let me know, or shall I proceed further? Any doubt in this section? Everything clear? Yeah, no doubt. Then we'll move towards the next part, that is the dimensioning. Okay.
Anyone? Any problem? Yes, Kailash, okay.
Okay.
Yep. Kailash, if you could brief us how to edit the dimension.
Sorry.
Editing dimensions.
Editing dimension, that is in the next part.
Okay, all right.
Yeah. So once you give the dimensions here, you can see the dimensions, you can view them. So let's say I wanted to uh, create a dimension between these two, and it is 8 mm. Okay, so I hope you can see this. And now I want it exactly at 10 mm. So what I'll do, I'll double click and edit it, and then you can give us 10 mm. So it will automatically change the dimension. Okay. Okay, so this way we can change the dimensions, and maybe for this as well. Let's say it is 3.1 and I want it as 5 mm. So you can use this dimension, you can change it. So normally you can give the dimensioning to any object like this. Let's say this is the diameter and I want it perfect 20, so you can give it. Okay, so this way you can give the dimension, you can edit them. You just need to double click on it and you can change it. Let's say instead of 5 I want as 10. Okay, then another one is a coincident. Okay, so why it is required, so you can see I have given dimension for this, so only this line changed, nothing else. Okay, so in that case what you need to do is you need to uh, change this point and this point as a coincident point. Okay, so what it will happen, this point and this point, they will coincide with each other, and then this point and this point also, and this point. So all the points are coincident now. Now though I will give dimension, now it will move completely. So let's say it is 11, I'll make it as 10 now, and then I can give the dimensioning. Okay, so let's say it is 30, and this is 20. Okay, so this way we can give the dimensioning very easily, right? And then next one is a midpoint. Okay, let's say uh, midpoint. Okay, so I want this circle at the midpoint of this line. That's all. Okay, so this is our midpoint constraint. So these are the various constraints. So what is use of this constraint? uh, So when you are giving a constraint, so you don't need to give the dimensions again. Why? What exactly it means? So let's say I am defining, like, the center of this circle and this point. So there is a dimension of 22 in between them. So no need to define that. If it is exactly at the center, and let's say if you have this line of 44 mm, right? So let's say I'll make it a horizontal line, and it is of 22, right? So no need to say it is exactly at that point. So instead of that, you can just give a constant as a midpoint, and it will be directly shifted to midpoint. So a constant help you to fix the degrees of freedom. uh, so that helps you to, you know uh, reduce the dimensioning. Okay, so then next constraint that we have is concentric constraint. So with this you can have a same center for different circle. Okay, so they will share the same center like this. You can see, though you have created it at different place, you can move it to the existing place, and that will help you to create a, the reduce the dimensioning again. Okay, and then next one is the fixed. So with this, what happen, whichever the entity you will select, that will be directly fixed at its location. Okay, so let's say if I want it exactly over here, I don't want it to move, I'll just fix it. But with before fixing, you need to make sure whatever the dimensions you are given, and whether those are correct one or not. Okay, so this way we can fix any object completely. Okay, like this. Then this is a horizontal constraint. So when you are creating any line at any inclination and you want to be exactly horizontal, just do like this. Then use this constraint for vertical line. So let whatever line you have, you can convert it into a vertical line. Then parallel line. So let's say I'll just create few more lines. Okay, so let's say parallel. Next one is parallel. Okay, so let's say I want this line parallel to this line. So you can see automatically they will turn to parallel line. So whichever first you are selecting for that particular line, it will take place those changes. Okay, and then next one is perpendicular. Let's say I want this line perpendicular to this one, so it will change to perpendicular. Then tangent line. So I want this line to be tangent to this one. So you can see it will be tangent now. I want a circle tangent to this. It will be a tangent one. Then equal radius. So I want radius of this circle and this circle equal. So now we have already given dimension to this. So this cannot be changed. That is the reason in this case second circle changed. Okay, so that is the point we have. Then equal distance. So when you are selecting two lines, they will fix the distance in between them. So this distance will be equal. With this eye, you can get to see whatever the constraints are given at different locations. So here you can see you'll be get to see these different constraints over there at different locations. You just need to click on this arrow, that will show you what are the constraints are available for that particular object over there. Okay, and if you want to delete any constraints, let's say I want to delete it tangency, this tangency, and this, all you can delete it. I want to delete this concentric circle, you can delete it. delete this fixed constraint. So any constraint which is given by mistaken, you can delete all of them as well. Okay. So this thing is also possible over here. And then uh, next one is auto constraint. So when you click on auto constraint, it is showing 48 areas where auto constraining can be done. So you just need to click OK. It will automatically add the constraints to those particular objects. You can see again when you select over here, you will be able to see the various constraints at that particular points. Okay, so this is how auto constraining will be done by default. Okay. I hope you understood all the constraints. Okay, so with this sketching part is completed, how we can do the modeling further, or how we can create a sketch. Okay, so I have just explained all the tools in this sketching. So is there any doubt in this section, or we will move to the next part, that is the 3D modeling. Any question in this?
No, Kailash, I think we can
Yeah.
move.
Okay, so we'll move towards the 3D modeling. So for that, I'll just create a rectangle. Let's say I'll create a rectangle at the origin of 50 by 50. Okay, that is a perfect cube square. Okay, and then once you complete the sketching, you need to return to 3D mode. Here we have this option to return to 3D mode. And whenever you create any closed loop sketch, that will be automatically converted into a surface body when you are returning to the 3D. So as you can see, I have returned to 3D mode, and here you can see it is automatically changed to a surface. I'll just do undo, that is Control Z. So you can see now it is a sketch, and here if you see in the sketch, these are the lines, but when I click on return to 3D mode, it will be automatically converted into a surface body. So that is how it will be done over here. Okay, very easily you can uh, convert any object into a surface. Okay, by coming out of the sketch mode. Then when you select come out of sketch mode, you can see by default it has selected this pull command. Pull is nothing but a converting this command can be used to convert any surface into a 3D model. Okay, so very easily you can do this pull use this pull option over here, and just in this pool click on select, and you just need to drag it, so it will convert that object into 3D. Okay, let's say I want to drag it or pull it by 100 give the dimension and enter it. Then you can see now that solid will surface will be converted into a solid body. If I wanted to remove a object, so let's say I wanted to create a hole on this. Okay, so I'll just select that surface, click on plane view, and I wanted to create exactly at the middle, and it's of let's say 20 diameter. Create it again, return to 3D mode, and now you can see this circle. I want to remove the material. So if you normally if you pull in forward direction, it will be adding the material. If you are moving in backward direction, it will remove the material. But if you just wanted to remove the material, here also we have option add, cut, no merge. So I want to cut it, so just click on cut, and then moving downward direction. So this is how we can easily remove the material. Okay, so that's how we can remove the material. Okay, then uh, this is very easily we can create a object. Now I'll delete this again. I'll go back to the sketch mode. Now from the 3D mode, how we can go back to the sketch mode? So you need to go to the design, then click on sketch mode, and then you just need to select the object. So this home view is for home view you have H. So when you press H key, it will come to home view. Then again select the plane and say look at. Now I'll just create a point over here. Okay, one point is created, and then return to 3D mode. Okay, and Once you done this, um, select that point. Now we are in a pull command. Okay, so you can see it is a point over here as of now, correct? And now what you do is drag it and you can give the dimension. Let's say I'm giving dimension of 50 mm. So now what happened? Now this point is converted into a line body. So what it means, whenever you are selecting a point and you are using a pull command, then it converts that line into a point. Okay, sorry, point into a line, that converts that point into a line body. And now select this line again, and then again drag it, and then it converts it into a surface body. You can give the dimension. So when you are selecting a line and when you are using a pull command, it converts that line into a surface body. Okay. Okay, so the surface is created. Now select the surface, and when you drag it, it can convert into uh, solid. Okay, so this way we can easily, create a solid from the surface. So depending on what you are selecting, getting me? Okay, depending on what you are selecting, let's say you are selecting a line, or when you are selecting a point, or you are selecting a surface, accordingly you will be getting the object. So let's say you are selecting a point, then you can convert that point into a line body. When you are selecting a line, then you can convert that line into a surface body. And when you are selecting a line and use pull command, sorry, when you are selecting a surface and use pull command, you can convert it into a solid body. Okay, so depending on the selection completely. Okay, and then uh, okay, uh, then when you are selecting a edge of this solid and just drag it downward, it will create a chamfer. Okay, you can give the radius, let's say 10 mm, enter. So you can create a chamfer. I have not selected anything, just selected an edge of a solid, and then drag it downward, it will create a chamfer, sorry, fillet. And to create a chamfer, select the edge, and you can see here mini toolbar is appearing, this one. Second option is to create a chamfer. Select it and drag it downward, it will create a chamfer. If you want to make it in an odd way, so you can give the dimension. Let's say in this it is 10 and this it is 5, so you can create it this way. Okay, so these things are also possible over here. Okay, then again when you are selecting a edge, and then you can see the next option. uh, Here you can see it converts that edge into a surface body. So extrude edge option. Okay, so when you click on that, then you can and drag it, and then this edge can be converted into like a edge can be used to create a surface. Okay, you can pull it in any direction. You can do this. Okay, if you want to, if you select a surface, then you can and add material this way. Again, add material this way or this way, however you want. You can do that very easily. So this thing is very easily possible over here. Okay, then next option is copy edge. So you can copy the edge over here like this copy edge option, and you can copy it somewhere in between wherever you want. Let's say I want it at 20, so you can copy that. And what happens with this, you get access to only that specific part of the solid, like it just filtered that surface so that you can access only that specific surface. Okay, so that is the beauty over here. And then again, if I do control Z, and then next option is creating a pivot point. Select the edge, create a pivot point, and in which direction you want it, you can create it. So this way you can give the angle, or it's in the dimension. It's like from the normal, you can give the dimension either in a positive or negative way. Okay, so that is how you can give it. So it is normally 0, and you can add it or subtract. You can give this inclination by giving the angle. That is the first thing. Okay, if you wanted to sorry, this here you can give the length. If you wanted to give the angle, then we have option that is draft. I'll explain that afterwards. Okay, now I'll just delete this, and I'll just simply create a rectangle again on this plane. And normally when we pull it in a normal direction, means in a perpendicular direction to the surface, or perpendicular to the surface. But if I wanted to pull it in a at specific angle, let's say I wanted to pull it at an angle of 45-degree, in this way I'll view in this, along this I want to create an angle of 45-degree. Okay, like this. uh, Length doesn't matter, you can give the angle 45-degree and return to 3D. Now I wanted to pull it at this angle. Okay, so what you do, select a surface, and then here we have pull direction. Select this particular line as a direction, and then you can see it will automatically pull in the that specific angle. Okay, so this way it is possible over here, and you can very easily give this pull direction. Getting me? So very easily you can give direction or angle in which you wanted to create this uh, extrude. Okay, at any specific direction. Okay, and then next option is we'll see this option first, or not this. I'll just hide this curve and pull it in normal direction. Next option is draft. Okay, so to create a draft, select the first face and then select another face, and then you can give angle. Now in this case you can give the angle. Okay, you don't need to give the uh, you don't need to give the what I can say, the length over here. Now what we saw pivot point, there we supposed to give the length. Here we can give the angle. Let's say on 5 degrees or 10 degrees, you can just give it and done. Okay, so this is how you can give the draft. Then third option is scale body. So to scale body, first of all you need to select the uh, body. Okay, so to select the body, first of all you need to triple click on it. Okay, it will be select about it will select the body. Go to the pull command, and here we have scale body option, and you have to give the reference point. So let's say this is the reference point. With respect to this, I can scale up or scale down. Let's say I want to scale it to 0.5, is make it smaller, so you can do that. So that is how scaling can be done over here. Okay. Okay, so next option is uh, revolve. So I'll delete this, and I'll just create a circle over here, a small circle, and return to 3D. So to create a revolve over here, you need to select this surface, then take this revolve command and then select the axis. So I'm selecting a default axis, that is Y. If you want, you can create any line as an axis. So let's say I wanted to create a any line as an axis. Okay, let's create it. Okay, so this is our line. I'll just create a axis. Sorry, it should be in a straight line. You can have at any angle as it doesn't matter. Okay, so now this is my axis. So select this object and then take a revolve command and then select the axis. And now you can use the pull full command. Okay, so okay, so you can see this is how you can create a revolve. Now this is complete 360 degree. If you want at any specific angle, so you can just drag it outside and you can specify the angle. Let's say I want 270 degree only and type. So it will create a 270 degrees only. Okay, so this is how it can be done. Okay, and then uh, now if you wanted to create a helix, select the object and just increase. It's very small actually. Yes, now it is. No, it's too large now. Yeah, like this. Okay, now I wanted to create a helix. So select this surface. Again, take a revolve command, select the axis, and then here enable the revolve helix option. Okay, revolve helix. Enable it. Then you can give the height. Let's say height is 150. Use the tab button to switch between the dimension. Like it's like 10 mm pitch, and then tapered angle. Let's say 2 degree. And I want to change the uh, 150. Right, I think minus 150 we can give. Yes. So it is minus 150, 15, let's say pitch and done. Let's say pull full, it will create a complete revolve helix. So this way you can create a helix very easily. Okay. Done. Then next one is a sweep command. Uh, For a sweep command, you need a profile and a path. Path should be on a perpendicular plane, so I'll just create a path on a YZ plane. Okay, and here let's say I have created a path. Okay, so this is the path I have. Return to 3D and you can see. Now this is your circle and then take your sweep option, then select the path and say pull full. So it will create a sweep. So this is how we can create a sweep command as well. Okay, so these all options, whatever this mini toolbar or mini ribbon you can see over here, it is in a pull command. When it is selected pull, then only you'll be able to see these options over here. Okay, so these were all the pull options. I hope you are getting this. If you have any doubt, please let me know, or we can move toward the next part. Okay, clear? Okay, I consider this as there is no doubt, and we'll move to the next. And next option is move. Okay, so this pull command, what you can see, it is again available in the design as well. Okay, so it's continuing from here. Okay, and two mouse operations are very simple. If you rotate the scroll button, that is the middle mouse button, you can zoom it or zoom out. Okay, then if you wanted to rotate it, press the middle mouse button, that is rotate. And if you want to do the pan action, then control plus middle mouse button, you have to press both together, then you can use pan. Same options are available here without using keyboard. If you want to use if you don't want to use the shortcuts, you can use options from here or from here as well. Okay, I hope you can track my cursor where I'm selecting. Okay, so from both the places you can do this way. Okay, so then move command. Next is move command. So to select a move command or use the move command, what you need to do is you have to select a surface. Let's say I wanted to give certain angle to this. So you can say now it is normal, but if I want, I can give the angle. Let's say I want to give angle of 10 degrees. Enter. So you can see now angle is changed. Okay, so this is how you can do it. If you are selecting a face, if you are selecting a whole body, you can rotate it in any of these three along any of these three axes. Okay, you can rotate it, you can translate it. You just need to hold this axis, you can translate it, you can give the length. For rotation you can give the angle. Not I'm showing you randomly, but you can give the specific angles and other things. Okay, so this is how you can use the move command. Then next one is a fill command. For this I'll need to create a object. Okay, I'll just remove the material over here, and now we can use the fill command to fill this material over here. Okay, okay, so to fill, select the fill option, select this face and this face both together, say okay, it will fill the material over there. That's it. So this is how we can use the fill command. Next one is a blend. Sorry. Next one is a blend. Blend is something where we can join two different sketches together and create a solid in between them. Okay, so that is also very easily possible over here. Okay, so that can also be done. Okay, so here for that we need to create two sketches. Okay, first one is on a plane. Let's say we are creating on XY plane. I'll select create a circle. I need to create another parallel plane. So how to create another plane? Go to the design, take a plane command and create a plane. So just select this surface, it will create a plane along it. So you can see over here this plane. Okay, and I just do this. Okay, so this plane is there, right? Now use move command to reposition this plane. Okay, select the plane and then move, translate. Let's say I'm translating by 100. Give the 100 length and done. So this is how we can translate it. Now on this plane again create a sketch, select it and create a sketch. Now here let's say I'm creating a rectangle and done. Return to 3D. Now these two different sketches I can join and create a solid in between them with the help of blend option. Select a blend and you can see it will create a solid. Just say okay and it will create a exact solid over there, right? So this is how we can create a solid in between two objects, okay, of different shapes. Then next one is a replace option. Okay, so for this I don't need this circle. I'll just create a surface over here. And what I need to do is let's say I need to create this specific shape over here. Okay, what I wanted to do now, I wanted to extrude this surface, okay, or extrude this solid, and on the top of it it should take this particular shape. Now to take this shape I need to first create a surface over here, and I'll just say up to this point I'll create a surface. Okay, and now take a replace command, take a replace, select this face and replace surface. You can see it will automatically replace till that. You can hide the surface and that's all. Clear with this? So very easily you can do the replace option, and that will help. Okay, now this is how we can use the replace. Now we have option next is tweak faces. Now we can control this shape on the top of it. Select this face in the tweak faces, and then you can use move command to move the control point. So let's say I wanted to move this control point. So you can see it is here also you can use this to change its shape. So you get more control over the shape of the these things. Okay, so you can see like this or this, like this. Okay, or if you want in upper direction like this. So this is, I'm just making you aware of this option. It can be used mostly in the what you can say, in a surface operations. Okay, then next one is a combine split body split and project. Okay, so here uh, we need to split this object first. How to split it? So take a plane. Now I'll hide this plane, select this plane. Okay, and plane is created. Now reposition it exactly somewhere in between. Okay, it should enter for this complete solid. Okay, done. Now use the split body option. Split body, select the body, select the plane along which you want to split it. Done. You can see now it is split into two parts. Delete, delete. Now you can see it is split into two different solids. Again, combine option is there. Combine, select the combine option, select the first solid and use this combine command and select second. Now again it will be combined. So this way we can easily combine or split the object. Okay, and then uh, with this next option is project. So for this we need again a surface. So I'll just take this outside and we'll create a, okay, now this, we'll delete this, we'll create a new on this side. Okay, and then move this somewhere here. Now I told you few options in from the sketching which I have not told you, right? First one is this project to sketch. Now my sketching plane is over here, but I want to take a reference of this sketch. So what I can do is project to sketch and select this. So you can see it will be projected to the this sketch, as you can see. Okay, so this is how we can use the project to sketch option. Done. And if I need it, you can just return to 3D. So you can see it will create a separate solid out of it. I don't need this. I'll just
Uh,
delete it.
I don't
Yes,
mind getting
yes
that
sir.
step because you for a moment.
Can you repeat, sir, what you said?
No, would you be able to replicate the command project tinker? We lost you for a moment.
This project command.
Yes.
Okay, yeah, so like so let's say I have created a plane which is away from this object, and I wanted to create a sketch of this shape of this particular object. So what I need to do is I just need to select this project to sketch option, then select the edges which I wanted to project, simply, and done. That's all. So you can see it will completely project that specific shape. If you return to 3D, you will be getting that as a complete surface over here. So this is how you can, maybe if you need to take its reference, in that case you can use it. Okay, I'll just remove this, and I'll just create another, I'll create circle over here. Okay, return to 3D, and now next option which I forgot to tell you, that is the face sketch. So whichever 3D face of solid we have, select that, and there you can create a this kind of like a sketch on that face in 3D you can create. Okay, so that is what face curve what option we have over here. Okay, then Okay. Next is next is I'll just convert this into a surface, sorry, solid. Yes, done. Now, next option here, what we have is project. Now I can project this shape on a solid. So this is also possible in 3D as well. And for that, this option is available. So you just need to say project to solid and say okay, so you can see it will project that. So if I hide this now and this as well, so you can see it will automatically project it, because if I wanted to create it this way over here, it is little difficult, but with the help of project I can easily project that. Okay, so that is what project we have. And in the next case, you have already seen this plane command. Next one is the axis. For axis, you just need to select the axis command and select any round body. It will create an axis passing through that. Okay. Okay, so this is how we can create axis. Next one is a point. How we created a point in 2D, same way you can create points in 3D. It doesn't mean we can create it randomly. We can use move command and to place them exactly at any specific location. Okay, so that is also possible. Let's say I wanted to put it over here. You can see on this edge, like, you can position it. Okay, so this is how it is. I can create a points and you can reposition them. Next one is origin. At any location, if you want to create a new coordinate system, so that you can create it over there. Okay, so this way we can create a coordinate system. And next one is a pattern, so which is very important. So I'll just show you that first, and I'll just create an object over here first. Mm, okay, I need to create a whole. Let's say I create it somewhere here. Return to 3D. Okay, so there are three types of pattern available. Okay, first one is a linear, second one is a uh, fill pattern, and third one is this circular pattern. So I have created one hole over here. I'll make a top view so that we can see it properly. Okay, a little 3D. Yes, then first one is a linear pattern. So select the object and then select any one direction. Okay, so you can see it has created a pattern over here. How many objects you want or how much count you want, you can give that. Let's say I want 5 count, and it should be in the x direction or negative x direction, that you can decide. Okay, I want it in x direction, so you can keep it as it is and you can say okay to this. If you want to give this pitch, change the pitch. Let's say instead of 10 I want it of 15. 15 is going out. Let's say 12, so you can give this, say okay. So this way you can create a pattern. This is a linear pattern. Again, in a pattern we have two options. One is one dimensional, another one is two dimensional. So in two dimensional you can give the y count as well. Let's say I want y count as 4 and y pitch as let it be 10. So like this, so you can create a linear pattern this way. Okay, so this is very easy to create again. Okay, then next one is uh, circular pattern. Okay, so for circular pattern, let's say I'll create a coordinate system somewhere here. Okay, and I'll create a circular pattern. Select the object, then select the axis of rotation for the pattern. Let's say I have selected this z axis. Okay, so now here how many counts I want? Let's say I want 12 counts. So you can give 12 in how much complete 360 or at any specific angle you need. Let's say I want in only through 270-degree. You can define that as well. Okay, in clockwise or anti-clockwise, that also you can define. Okay, so then say okay, it will create a circular pattern. Now here again two dimensions are available. You can create it inward or outward. So let's say I want it at outward. in the outward direction, but the y pitch I want it as, let's say, 5 mm. Okay, like this I can create it, say okay, so it will be created. So again, in the circular pattern also there are two types. One is the you know uh, in the circle, two types, like one dimensional and two dimensional. Okay, and then last option is fill pattern. So in fill pattern you just need to select the fill pattern and select any one edge of the rectangle, and it will be completely filled within that particular surface. Okay, here you can give the spacing. So let's say X spacing I want of 2 mm, along Y let's say I want of 3 mm, and margin. So this dotted line is margin. So let's say Y will keep it as 1. So it will go till the end. Okay, and I want this margin, let's say, of 3 mm. So you can see this dotted line will shift in inward direction, so that it will keep that much margin over. Say okay, it will create a rectangular or fill patterns. Okay, so this is how different patterns are available over here. Clear with the pattern? And then now we should move to the next part, that is uh, shell. Okay, so in shell you can simply convert any solid object into a shell body, and you can just select any faces which you don't want. So you can simply click on it, so it will be deleted. And now shell thickness is, you can see by default it is 1 mm. If you want you can change it. I want it 2 mm, it will be changed to 2 mm. So this way you can create a shell body. Okay, as you can see, whichever faces you don't need you can just simply delete them. Those faces will be removed. Okay, you have to select from the side, and those faces will be deleted. Okay, this one, this one, this one. Okay, this way you can delete it. Okay, this is how we can do the offset. Next one is the sorry, this that was a shell. Next is offset. Mm, in the offset we need to create a mm, yes, this split command I missed. So here you can use the split command to split the faces. Okay, so let's say I wanted to split this face. Take a split command, select the surface, and you can split it either in 4 parts or 2 parts. When you take a cursor towards the edge, it will split into 2 parts. If you are taking to in the middle, it will split into 4 parts. So let's say I want to split it into 2 parts. So you can split this way. Done. So this way we can split it, and then we'll come to the offset. Now before that, if you see here, if I select this face and pull it, now I can pull it standalone. Okay, there is no relation between, let's say, this and this face, or this and this face. Okay, this face. Okay, but when I use the offset command and I fix this distance, okay, now it is fixed. Now if I use pull command, you can see they both will be pulled together. So that is what offset what we have. Okay, then next one is the mirror. Again it is similar way we can create a mirror how we created in a uh, what you can say in a sketching mode, right? So same, take a mirror, but here instead of taking sketching axis or mirror axis, here we need to take it as a plane, and then select object, so it will be cannot created as a mirror. हाँ, ठीक ठीक है। Okay, so this way we can create a mirror object. Okay, done. This is how about various modeling tools. Two more are available. I'll delete this and then go to the equation. Next option is equation. So here you can see we have some standard equations available over here to create a surface. Okay, here you can see you just need to give these two parameters as an input, and okay, it will create a object. So let's say, hey, instead of helicoid you can create a paraboloid, and here you can give the and end as, let's say, 10, and scale it by 2. Okay, like this. Okay, so you can give the this parameters, and you can create an object. So this is from the uh, any equations which are existing over here. If you want to create your own equation, that also you can put it, and then you can set up the parameters, and that also you can use over. You can see the radial wave as well. This way you just need to give the input. So let's say your radial is 2, instead of that I will give 4. So you can create it this. Okay, then just simply say okay. You can use it for further modeling as per the requirement. Okay, you can use a rectangle from the bottom side, and you can use the blend command, right, to convert it into a solid. So this way you can use it. And then next option is cylinder and sphere. So you can create a cylinder or sphere directly without anything. So you don't need to create a circle and then pull it. Okay, so just select the cylinder, select the start point, give the axis, and then give the diameter. It will create a cylinder like this. Okay, and then the sphere can also be created the same way. Select a sphere, select the point, and then give the diameter. So it will create a sphere. That's how very easily you can create a sphere or cylinder. So that's all about the modeling part. If you want me to repeat any specific command again, please let me know. Otherwise, we'll move to the next part. Yes, any doubt, any thing you want me to repeat, anything which is not clear to you? Yes. So all clear? Okay. So
Okay, Kailas, I think we can move ahead.
sure. So next part is geometry repair. So what is exactly geometry repair and why we need geometry repair? So someone of you might be aware of any other modeling tool, right? So maybe Creo, CATIA, or any Unigraphics kind of different tools what you have, right? Or AutoCAD something, right? So when you are using a modeling tool, and when you create a model in some another tool, when and after that you're supposed to do the simulation on it, right? So you should import that model into the Ansys. So when you are importing the model into the Ansys, so there will be certain data losses. Okay, so after the import, so what kind of data losses it happens and why those happens? So see, the algorithm used in different tools is different, right? So whenever you are importing that model into the Ansys, so there are chances of getting certain data losses. So what kind of data losses? Like some edge is splitted, means like a continuous edge that is splitted into two parts. Any surface is missing out from object, or any extra edges created or extra points are created. So this kind of issues you will be able to see in that particular problem, right? So what we need to do is we have to repair that, and we have to make it ready for the simulation. Okay, so that is the main purpose of using the repair option. Okay, so we have seen this sketch design, and next we are going to see the repair options. Before that, what are the different file format that ANSYS supports? So go to the file and open. Here you can see various file formats in which can be imported into the space claim. So you can see we have some direct file format from Criteria, Creo, Unigraphics, Solid Edge, SolidWorks, etc. Okay, then there are some standard file formats like IGES, then Parasolid or Step file. Okay, so whenever you are importing any model from any in any specific file format, so there will be certain data losses. So it is preferred to import in a specific standard file format like step file, parasolid file, or IGS file. Okay, so the definitely it's not like you will not get any kind of data losses. So there will be certain data losses if you have some complex object, right? So in that case, what you need to do is you should import a model in a standard file format, that is parasolid, which can give you the less data losses. And then if that is not supported in that particular tool, then you can export from that tool in a step file or in a IGES file, and then you can import it over here. So let's say I wanted to open a file in a parasolid. So what you need to do is, you can see it now, it is the filter is to specifying file. So whenever I am clicking on open, it will show only specifying file. Then I wanted to change it to all files, so it will show you all the files over here. And I wanted to import a parasolid file, so this is a turbocharger parasolid file, that is turbocharger.x underscore t. So this is a parasolid file format which I wanted to import over. Select the file, click on open, and it will be imported over here. Okay, so this way you can import it. Now this is a parasolid file, what you can see over here. Okay, so what we need to do is first observe the model over it. So you can see this model. Now this model is of turbocharger. It has different models, or you can say components inside that, and we need to you know select the specific components, or repair this to make it a completely watertight geometry, and then extract the fluid domain out of it. So why exactly it is necessary? So when we are solving a problem for the CFD simulation, we need to make sure that we can extract the complete fluid domain to solve the problem for the CFD simulation, right? So that is very important over here. So in for that particular case, what you need to do is you have to remove all the we can say what are the um, uh, missing things are there, which we need to add it, and we need to make it completely repaired problem or repaired model. And then we have to make sure that it is completely watertight, so that we can extract the fluid domain. If there is certain leakage, then it will not be possible to extract the fluid domain. Okay, so that is the reason we should properly extract the fluid, properly make a watertight geometry first, right? So if you observe this model, so here you can see there is a left side casing we have, then this is the right side casing, this is the surface. Again, you can see these two are surface. If you see the symbols for this, so this is a surface symbol, right? So this symbol, what you can see over here, right? So these are the surface bodies that you can see. So what exactly it means? So these surfaces need to be first converted into solid. So that is what you need to observe over here. Then this is the middle casing, then this is the shaft, Then this is the blades, another impeller blades. Then this is some flange is there, and then this is the washer, and this is the board. Okay, so all the components you can see. Now first of all, if you see these two are a separate surface and it should be a single body, or again it should be a solid body. So what exactly it means, we should combine this first. Okay, so convert this into a single body by using stitch commands. Click on stitch, and when you select it, here you can see it will show you information found one area. Okay, so click on this, uh, add a new area. Okay, so click on it and it will combine it. So just you can see now it is still showing as a surface, but as a single surface over here. Okay, okay, so it is showing as a single surface over here. Now both the surfaces are stitched together, and now it is showing it as a single surface. And now what we need to do is we need to check for next, that is if there is any gap. So again it is showing no gaps found, and next one is to go for the uh, go for the next check, that is the missing faces. So if you click on missing faces, now it is showing found one area. So still it is a surface body. Why? There is a face missing over here. Okay, so when we will add this face, it will convert that face into add that particular face and convert this surface body into a solid. So just click on it and you can see it will be added. Okay, so this way we can add another face. Okay, and now it is converted into solid. Yes or no? Don't go on the name. Still name is showing as a surface, but symbol is important, and symbol what you can see it is of solid. Okay, so symbol is important over here to understand. So now the model is converted into solid. Next thing you need to check, that is the split edges. So you can see there are two areas found for the split edge. One is the over here, here you can see, select on it and click on it, so it will be repaired. Another one is somewhere here inside, so it is something on this object, okay. So I'll just hide that and I'll inverse the visibility. It will show only that object now, and here you can see if I'll try to remove it, it is not removing. Why? It is not a split edge, it is actually a extra edge. So what it means, it has converted into a extra edge. Okay, so what we need to do over here is we need to delete this by using the extra edge command. So click on it and it will be removed. Now extra edge is removed. Again show all bodies, here you can see, and again perform this command. Okay, so this is remote. Now what you need to do is again need to check, so whichever objects will be visible only for that command will be executed. Okay, that you need to keep in mind. Now again I have made all the objects visible, so I need to perform this command. Okay, and again you can see it is showing one area found, somewhere it is on this flange. So again I inverse the visibility and you can see over here. Okay, and again select on it and remove it. Okay, and it is removed. Again show all bodies, and now it is done. Model is properly repaired. Now you can see the next command, that is the duplicate. So again it is showing found one area, where it is over here. And what exactly it is showing now? It is a face of a solid. When I try to delete it, what it is showing, cannot remove face from a solid. So the face of this washer, that is taken as a duplicate face, so no need to remove it. So just neglect this and then go for the next step. So what is next step? You need to check for the any gaps or you know okay. So need to check for the interfaces and the gaps now. So first let's see the interfaces. So here we have option in the prepare interface. Click on interface and it will scan the body. So you can see it is showing inspecting bodies, and here found two areas. So there is a interface in between these two. One is over here and another one is over here, right? So if you want to view it in different way, go to the display, change the graphics to wireframe model, and here you can say one is here and another one is here. If I try to delete this, what will happen? It will make the object weaker. Okay, so as you can see, I have deleted this. Here you can see object become the weaker now. Okay, so okay, object became the weaker now, right? So it is not advisable to reduce the objects dimension, so that it will not sustain the design point for which it is designed, right? So you can add the weight or you can add the material, so that will anyway strengthen the model, but it will not remove the material. What is it will not decrease the strength of the model, right? So you can add the material but cannot remove, right? So another way is to find out how much this interference is and move this left casing towards the left side by that much distance. So to find that, go to the measure, and here go for this measure option and measure this distance. So from this to this, so I can see minimum distance between the objects is 9 mm. Okay, so go to the design, take a move command, triple click on a surface to select a whole body, and hold this red axis and move it by 9 mm. Enter, and now you can see it is properly positioned over here, right? Again again check for the interfaces. Okay, and again check for the interface, go to the prepare, check for the interfaces, and again it is showing interface and inspecting the bodies, and now it is saying no areas found. So what happened? This blades, they were interfering with this casing, that is also removed. So with the one step, both the interfaces are removed. Now you can see interface is removed. Another thing is to check the gaps. So on the outer side there are only three objects or three casing parts. One is the left casing, middle casing, and right casing. So here we have already made the surfaces aligned to each other, but here if you see, it is showing certain gap over there. So what you need to do is we need to hide all the other components except the on these two. Okay, so okay, I'll inverse the visibility and only these two I'll make it as visible. And what we need to do is we need to add a material over to fill this gap. So take a pull command, this face, no need to measure, you can directly say up to this face. Done. So gap is filled. We can view all the bodies together, show all, and done. If you see gap, there won't be any gap further over, right? With this we made a model as completely watertight. Okay, and now what we need to do is we need to extract the fluid domain out of it, correct? How to extract the fluid domain? Go to the you know uh, prepare, and here we have volume extract option. And now we made a problem up to date. So how we created another tool, same way we created it over here. Now we need to take a fluid part from that particular object. Let's say this is an internal flow problem, right? So we just need to take a fluid part out of it, right? So to do that, go to the prepare volume extract, select this edge selection and select this edge and this edge. You should select a complete edge loop of the openings. Okay, now there are two separate fluid sections over here. One is the left side and another one is the right side. So first I am selecting the right side, both the openings, whichever openings that you should know. Apart from the openings which you should know, there should not be any other opening. What it means, that opening will be considered as a leakage, because you don't know and still it is existing over there, and that what it means, fluid will be leaked out of that opening, but which you don't know, right? So that is the reason you should not um, keep any such kind of opening. Okay, so you should know all the openings and you should select the complete edge loop of the openings, inner edge loop of the openings. Let's say this is how I have selected. Just click on OK, it will extract the fluid out of it. Okay, creating volume. So you can see volume is created. Similarly for the left side also we need to create it. Again, go for the volume extract edge selection, select this edge and this edge loop. So you can see I have selected again both the inner edge loops. Say okay, again it will create a volume out of it. Okay, then once it is done, now I will hide this too and I will inverse the visibility. So you can see this is the fluid domain inside this complete turbocharge. If you want to view in a sectional view, select a create a plane. Let's say I'll create it on like YZ axis, and then right click on a plane, clip with plane, clip. So it will cut over there, and then you can see the cut section. So this is how it you can create a section, and you can see now this is part is no, the part which is remaining or which is hollow inside the turbocharger, that will be extracted as a fluid domain. Okay, I hope you're getting this. Inverse the visibility, I'll say show all, and you can see this is how we can extract the fluid down. So that is how we can repair the model and we can prepare it for the CFD simulation. So that's all. If you have any doubt in this repair part, so this was the last part of space claim. So if you have any doubt, please ask. No doubts? Okay. Yes, any doubt, anything? So with this, I hope this PES claim is completely clear to everyone. So you can see when you create a model, then if you go back to the workbench, you will be able to see green tick next to the geometry. If I take a, this, there it is, component system, you can see it will be showing a question mark initially, but when you create it, it will show as a green tick. So which means model is completed or model is created. Okay, so that's all about the space claim. Any doubt in this? Okay, I think then we can stop over here. Again, we can meet at 2. So from 12:30 to 2 we have break, and then we'll continue from 2 to 4, in which we'll learn about the meshing, and then we'll move towards the mechanical side. Okay, I hope it is fine, sir. Yes.
Yes, Kailas, that's how we have communicated. So
Yes.
kindly share these files with us, Kailas. Now I have spoken to Sneha as well on this. So then
Yes.
attendees can also work simultaneously as well as later on with the records.
Sure. This file, I'll share it right now, and as we'll proceed further, whatever the files will be there, I'll share all of them with you, right? So you
Oh,
can
okay.
practice it.
Yes, that'll be awesome.
Yeah. Yeah. So, okay, then see you at 2 p.m. Yeah.
Okay, Kailas, yes, thank you.
Yeah. Thank you. Thank you, everyone. In the meantime, you can practice it. I don't know how is your break timing. So accordingly, you can plan it. You can practice in the meantime, and then you can, if you have any doubts, you can ask me, in the second session. Okay. Thank you.